I recommend not getting scared about this equation. It's known as the Bernoulli equation, named after one of the many Bernoullis. I forget which one, but I think one of the Bernoullis. Uh, it's essentially a rejig of the conservation of energy. Uh, Now, if you've done a bit of conservation of energy with springs, I don't think we did that in simple harmonic motion. You'd be familiar with mgh naught plus a half mu squared plus one half kx squared, kx naught squared is mgh1 plus a half mv squared plus one half kx1 squared, or something to that effect. This is essentially just that, but it's to do with fluids. So in a closed pipe system with a fluid of constant viscosity, the absolute pressure, gauge pressure, and dynamic pressure of the fluid is constant in the system. Now, I haven't covered dynamic pressure, but that's this fella here. So the dynamic pressure is one half rho v squared. Almost like the formula for kinetic energy. And it's called dynamic gauge pressure because dynamic refers to movement. Yeah, that's essentially it. Pressure is sustained as it's moving. Now, when does this actually apply? Well, what we're saying is that the viscosity has to be quite low. It tends to be like less than one. So pretty much like water. Um, this is known as inviscid flow. It's not really something that tends to be of common knowledge, but there you go, inviscid flow. The flow must also be laminar, so we can't have turbulent flow. And as well as that, the fluid hitting off the circumference of the pipe may induce molecular friction, as well as the fluid particles getting stuck on the top of the bottom of the pipe. So we essentially have to consider no friction in it, but we're allowing this. We're discounting all forms of friction. So no viscosity and no friction. So whether that be static, dynamic, or kinetic friction. Now, for most of fluid dynamics, this word incompressible is pretty key. Most fluids tend to be, but when we're discussing things like air and other gaseous things, they can obviously be compressed. And so we'll mostly be focusing on liquids. The fluid as well must not encounter a heat source. Again, this is another popular assumption that the temperature is constant. This is also from Boyle's law that we did a couple of videos ago. So there's just a few things just to keep in mind.